So for the first panel of the symposium, we have a number of launch and propulsion providers represented up here. It's great to have several first-time speakers here in Colorado. And to lead the discussion, I'm delighted to welcome the senior editor at Aviation Week and Space Technology, the peerless Mr. Frank Moehring Jr.
Thanks, Phil. Thank you, everybody. Thank you for being here. This is kind of a good day to have a launch panel. Some of you, I guess most of you by now, have seen the pictures of the shuttle Discovery flying over the monuments in Washington. And if you've read your email, you know that one of the potential replacements for the space shuttle, which is on its way to the museum at Dulles, has passed its, at least preliminarily passed its flight readiness review for an April 30 launch, and Gwen Shotwell from SpaceX is here among many other distinguished panelists to talk about the inevitable transition that is going to follow the retirement of the shuttle fleet. A lot of these guys have been taking us to orbit for a long time, or their companies have, either as launch service providers or engine makers, and I think they're all in a very unique position to tell us what to expect in the coming decades and certainly the coming years. Let me just go through the list real quickly. You have it with you, but I'll go through it. Starting at my right, we have Dan Collins, who's the Chief Operating Officer of United Launch Alliance. Next to him is Jean-Lin Fournereau, Deputy to the Chief Operating Officer and Corporate Senior Vice President Space at Safran Group in France. We have Jim Mazur, who you all know. He's the President of Pratt & Whitney Rocketdyne. Clay Mowry, next to me on my right, is the President of Ariane. I'm sorry, where'd he go?
I'm here, to the left.
On my left, Clay Mowry, who's the President of Arianespace. I miss Frank McKenna, who is the President of International Launch Services. And to Clay's left is Charlie Precourt, who has been to space, and he's also the President and Vice President and General Manager of Space Launch Systems at ATK. Next to him is a very good friend of mine, Julie Van Cleek, who is the Vice President for Space Launch Systems at Aerojet. She's filling in for Scott Seymour, who you see on your program. And finally, Gwen Shotwell, who's the President of SpaceX. And the way we're going to do it today is each of the panelists will present a presentation. I may kick it off with a couple of questions. Somewhere they're going to put up a text number and use your smartphones to send questions to me. I can read them right here, I think. And I'll pass those along to the panelists. Panelists, I'll direct the questions to you. Speak from your seats. And if you want to follow up another panelist answer, just raise your hand and I'll call on you. So with that, why don't we start off with Dan Collins from ULA.
Well, great. Thank you, Frank. And it's a pleasure and an honor to be part of the panel today and to address the symposium. I'd like to congratulate Frank on your recent recognition from the National Press Club. Congratulations. That was terrific.
Thank you.
And also, just looking back to last night, congratulate the Kepler team, as United Launch Alliance was very proud to be a part of that team and put them on their way to the great success that mission has been. Let's see, we'll bring up some charts, I hope. I'll click and see if that happens. There we go. So, one more. ULA is proud to have been a big part in supporting the Air Force, NASA, and the National Reconnaissance Office, and really what's been an unprecedented run of reliability over the past years. You can see up on the chart all the payloads that have been put into place by the EELV. You can see the breakout between national security, civil, and commercial, playing in all the different markets and providing absolute mission success to those customers. If you try to add up the value of those payloads that have been put into space, you really can't do it because some of them we can't talk about and really understand it, but you'd be in the tens and tens and tens of billions of dollars of payload put into space very safely. But it's really not just about the hardware. What's really important in my mind, was emphasized a little more than 9 years ago on 20th of March 2003 with the beginning of the invasion of Iraq and putting hundreds of thousands of our soldiers, sailor, airmen, and Marines into harm's way. And the capability that those payloads have delivered, I don't know if I can put any price on that, and I'm not sure if there's our people in harm's way who can. It basically gets to priceless when you start to look at the capability that the Air Force, the NRO, the whole national security space has delivered. And then you put on top of that the amazing accomplishments that NASA, and really when you get one shot in the NASA budget today, you don't get do-overs when you've put the type of effort, hard work, and money into these really, really cool science experiments. It's hard to put a cost, and it's that background and that capability in science and national security and in spreading freedom around the world that we need to look at how do we go forward. And that's really, you know, the theme of this panel. And I think we need to make sure that when we look at what are our options to go forward, that we're keeping this in mind, that this is what's being delivered. We're not buying rockets. We are delivering payloads, but what we're really delivering is the capability that you see on this chart between wideband global SATCOM, advanced EHF, and you can read these things, going to Pluto, going to Mars. We don't get many shots. So it's something to do with a lot of thought and to do it as smartly as we possibly can. The next chart, and for the good news for you, this is the last chart I've got, really talks about the system flexibility so that we're ready to put that capability into space when that capability is ready and not have to wait on when the rocket's ready. And this chart's just the latest one that we've put together, and you can see on April 3rd, 4th, 5th, and 6th, between launching on the 3rd, erecting a heavy on the 4th, encapsulating a payload on the 5th, and then offloading the next rocket on the 6th. We're going coast to coast, we're going system to system. We're able to support with flexibility to be there when our customers need us to be. And we think that's very important. So you can't be on the launch panel without bringing, or at least I can't, without bringing one cool video. It's pretty short, but I want to highlight the launch success that we've had since the beginning of the year. So if we could please roll the video.
ROC, report range, go for launch.
Ranges go. LC, go for launch.
Roger, go for launch.
This is Delta Mission Control at T-minus 5. Main engine ignition. And liftoff of the United Launch Alliance Delta IV rocket carrying WGS-4 for the United States Air Force.
Gotcha. Go Alice. Go Centaur.
We have ignition, and we have liftoff. Liftoff of the United Launch Alliance Atlas V rocket carrying the first Mobile User Objective System mission for the United States Navy. MUOS will significantly enhance communications for U.S. forces on the move.
This is Delta Mission Control at T-minus 5. Delta engine ignition, 1, 0, and liftoff of the United Launch Alliance Delta IV rocket carrying the NRO L-25 mission for the National Reconnaissance Office.
So thanks for putting up with that video. And in closing, the one, I've talked about reliability, capability, flexibility, and certainly the panel has to talk about affordability. There's no way to escape that. It is going to be the key topic we talk about. However, I think we need to talk about it coming from with that picture of the capability and the idea, or in my mind, the truth, that this is about supporting science and our people in harm's way. And we need to move to affordability, having established reliability, capability, and flexibility. And with that established, to make sure that we never let our people down, then we move towards the affordability. And that's what ULA is doing today. We support the Air Force in their efforts for their new acquisition strategy. We don't think it's one way or the other. There's over 50 launches that need to be launched in the next 5 years. A block buy will significantly lower the cost of providing many of those launches with the same reliability, capability, and flexibility. At the same time, leave plenty of launches there for new entrants to establish themselves, to meet the criteria, and to be a part of this game. We welcome the competition. I had a chance yesterday to meet with the new generation that's here at the conference and to go through speed mentoring. And it's very clear to me that in 20, 30 years, these are the people who are going to look back on how we've handled the situation today as the space leaders. And the one thing that continues to occur to me is that we won't be judged on how widely we employ competition. We'll be judged on how wisely we employ competition. There is the right way to go about it, there's room for it, and it can be a strong market mover and a great tool for our customers to use. We just need to use it as smart as we possibly can. Thank you for your time.
Thank you, Dan. And next is Jean-Lin Frondereau from Safran.
Thank you, Frank. Good morning, everybody. I am very pleased to be part of this outstanding panel. And I would like to thank the Space Foundation for inviting me. And I am discovering that I am the only one non-US speaker. So it's a great honor to me to be part of this panel. So I would like to introduce you Safran Group. I am not sure that everybody is well aware of what is Safran. So Safran is a global leader in aerospace, defense, and security with a global market, and I'm sure few people are knowing that. Our customer number one is the US Department of Defense and not a European customer or European country. We have a very strong presence in the US, 6,500 people in 22 states, in 58 locations. So this footprint is increasing year after year. We are definitely R&D focused, and we enjoy market leadership position with very strong brand name in propulsion system. It's CFM, of course, SNECMA, Heracles in solid propulsion, Turbomeca for engine helicopter, Microturbo for missiles. In aeronautics equipment, Labinal for wiring system, Messier Bugatti Dotti for landing gear and braking system, avionics with Sagem, Hispano-Suiza, and security, which is increasing more and more through our new company Morpho, which has a very huge footprint in the US through Morpho Detection, Morpho Trust, and Morpho Tract, which are the former G Detection and L1. We are R&D focused, and we are also cooperation focused. Technologies and cooperation are definitely our DNA, and we are enjoying 40 years of experience partnering with the US federal, state, or local government, and also with industrial partner, and especially through our 50-50 joint venture with General Electric, CFM International, which is definitely the world leader in the field of commercial jet engine. We have more than 25,000 engines under operation. Every single Boeing 737 is CFM equipped. That means that this Boeing has 50% coming from Safran. And we are used to say that every 2 seconds, somewhere in the world, there is a CFM powered takeoff. Safran in space. We are involved in space propulsion now for more than 50 years. We think that we are number 2 worldwide in solid propulsion through our new company, Heracles, which is starting very soon, and which is a merger between the 2 former Safran company, SPS, Safran Snecma Solid Propulsion, and SME, SNPE Energetic Materials. So now, through Heracles, we are mastering all the technologies and products related to solid propulsion, from energetic material, ammonium perchlorium, rubber, pyrotechnics, carbon nozzle, carbon composite, booster loading, combustion simulation. So we are mastering all those technologies. In cryogenic, is the same. We are working on cryogenic propulsion for more than 50 years. And we were, in fact, the second to develop cryogenic propulsions in the early 60s. Now we have accumulated 50 years of experience through various engines, per stage engine like HM7 or core stage engine like Vulcain 2, which score 47 success in a row with Ariane 5. So here also on cryogenic propulsion, a very strong and experienced background for this propulsion. And also in electric propulsion for satellite, we are working now for more than 30 years in all effect technologies, which is flight-proven, and we are about to equip several kinds of satellite, small GEO or big telecom platform. So what is our ideas regarding cooperation? As I said previously, we have a huge experience in this field, and we think that we could offer transatlantic cooperation at 4 different levels. The first one is at Ariane 5 system level, using also a Kourou facility for the launching base. And as we already did last year, and I took this example of hosted payload, it was the commercial hosted infrared payload, which was launched by Ariane 5 end of last year. We have to have in mind that the James Webb Space Telescope will be launched by Ariane 5 from Kourou. And more generally, we consider that Kourou and Ariane 5 could be used as a NATO space base for backup. So it was at system level. At stage level, we are strongly pushing forward the Liberty project. I am sure Charlie Précourt will give you later on some details. We are convinced that this project is a very smart project, low cost, low risk, very well-defined, already human-rated product which are under production, and it could bring a solution very quickly and also in the frame of transatlantic cooperation. So we are really convinced that this project is very smart and very optimized. At subsystem level, we consider that we could bring solution regarding the EELV's system. My neighbor described previously those systems, and we are considering that in the frame of the new common upper stage project, which could be developed in the future, with our Vinci engine, which is under development and which will be qualified very soon in the next few years, which is a very modern, restartable expander cycle engine, we could bring optimized solution to the ELVs. And last level, at equipment and component level, we are already partnering with some US industrial companies on the CMC nozzle, and it's with my left neighbor. We are partnering with Pratt & Whitney and ULA for decades now, where we are producing the extendable carbon nozzle for the RL10. In electric propulsion, we have currently discussion with some US partners. In space optic, you have to know that on the James Webb Space Telescope, there will be optics coming from Safran. The same for pyrotechnics, wiring. We have our company, Labinal, based in Maryland, which is already partnering with ULA on wiring for satellites. So this is, in our mind, the 4 different levels of cooperation we could have on a transatlantic basis. And so I will... as a matter of conclusion, we are convinced at Safran that in the current context where we have a budget constraint, where there is more and more globalization, there will be a need for developing international cooperation, and more specifically transatlantic cooperation. And we think that at Safran, thanks to our state-of-the-art product technology, our US footprint and transatlantic expertise in defense and in cooperation, we could promote innovation and cooperation, and we could accelerate space access and exploration with ready for the market solution. And we think that this is the way to move forward the cooperation for the benefit of human beings. So it was supposed to have a few photos for Liberties, Ariane 5, and ELVs. This is the 3 levels of system we are pushing for partnership. So the photos are not coming. I hope that the video, the very short video, will come showing some ignition of our engine. So if you please, start the video.
Never gonna, I can't.
And just a word of conclusion, Safran, the space engine you can rely on. Thank you very much.
Thank you, John Lynn. After all those nice videos of rocket engines, it's appropriate for Jim Mazur to take the stage.
So I don't have any videos or PowerPoint, but I think I have something to say. So a comment I've made over and over, and I think I've been clear and continue to say, that it's difficult to address problems or identify real opportunities until we decide as a nation what resources, assets, and capability we need to ensure our strategic and scientific access to space. Security and defense, communications, observation, exploration, both robotic and human. We need to decide, we need to commit to it, and we're running out of time for studies and lengthy business case experiments. John Logsdon of the Space Policy Institute said, "Space exploration is now a discretionary activity, not a national imperative. This country's leaders need to decide under very difficult circumstances whether their image of the U.S. future includes continued leadership in space exploration, and then make the even harder choice to provide on continuing basis resources adequate to achieving a leading position." In the absence of that, I think for industry especially, I certainly know for every business I've been in, there's a huge risk in any investment strategy. Not that the technology won't work out. When we invest in technology, we don't expect it all to work out, and in fact, we expect a minority of it to work out. But even if it does work out, the direction you have invested in will change again. And at PWR, we have been investing. Over the past 15 years, we put over $750 million of our money into our propulsion technology and developments. We developed the RS-68, the world's largest liquid hydrogen engine, commercially with our own money to serve an imminent growth in commercial market. It was certified in 2001. The first flight on Delta IV was 2002. 19 flights, including 5 Delta Heavies with 29 engines flown. And we continue to invest in manufacturing technology to find ways to make it lower cost. And we've partnered with the U.S. government to upgrade this engine to an even larger, over 700,000 pounds of thrust with the 68A. We continue to invest in the RL-10. We've been evolving it for years for improved performance and affordability. 425 RL-10s have flown, powering 215 Atlas, Delta, and Titan launches. This engine's been ignited over 15,000 times and has fired for over 2.3 million seconds. And we continue to invest and evolve that engine. We've also invested in domestic production of the RD-180. And I don't even want to discuss our investments in programs that have been canceled over the years, but we're still leveraging the technology. In addition, we have over 35 years of experience with reusability with the Space Shuttle main engine. And we're leveraging all of our experience and investments into our recent engine developments. The J2X last year ran full power, full duration on its 8th test. That's the fastest we've ever done it in our history, and it's because we're leveraging our investments and our experience. Our launch aboard engine, which is a liquid launch aboard engine for the Boeing CST-100 commercial crew capsule, we just fired that a few weeks ago and demonstrated nearly 40,000 pounds of thrust, going from 0 to 40,000 pounds of thrust in about 100 milliseconds. So I don't understand comments like we have not invested in propulsion technology or the technology is old. That's simply not factual. We've invested, but with a lack of stable, consistent direction and market demand that did not materialize, I can tell you the return on this investment has not been good. In addition, there really is no magic technology. As much as you all, a lot of us about the same age as me, grew up watching Star Wars, and I love watching Han Solo take off and fly up to that, go into space, and go into light speed. As hard as we've been working, we don't know how to do that. And I guess with the attitude today, since that was in the 70s, that'd be old technology. So we continue to work on it, I can tell you, but we can't get there. And when you look at the most recent records of development and flight successes, the Delta II, Delta IV, Atlas II, III, and V with ULA and their parent companies, and the SSME record on shuttle with NASA, I think people are starting to believe it's easy, especially those people who have no experience with launch failure. And since it is easy, it should be cheap. If you have a clever modern design with a US government customer with the laissez-faire management techniques. Well, for the foreseeable future, the only way we have to leave the planet is chemical propulsion. I wish it was different, but I can tell you everything we're working on, the closest thing we got is hypersonic technology, and we're developing that, but it's still chemical. And the rocket equation, unfortunately, pushes to relatively high-performance propulsion and relatively lightweight solutions, which drives to the designs you see all around the world in many different configurations, but they're ultimately similar. And when we talk about cost, There are many different elements, and design cost is one of them I'd talk about. But due to the rocket equation and performance and weight requirements, driving vehicle mission requirements, it's really the hardest cost to significantly change because you still have to leave the planet. In fact, RS-68 was specifically commercially developed by us to reduce non-recurring dollars and time and reduce recurring costs, and we allowed the ISP and the weight to increase relative to traditional engine designs. We have an ablative nozzle, for instance, which is heavy but low cost. And we did this engine in half the time of SSME and at 20% of the cost of SSME. So it is possible, but there are other elements of the cost that are very relevant because these things still have to be rocket engines. So what remains for cost? Fixed cost is something we can address, aligning capacity with demand and better utilization of fixed assets. A huge, huge driver on cost is volume. Volume of launch and volume of production and volume in the supply base. You get economies of scale, learning curve, and a healthier supply base down the line. The risk posture of your customer. If you're launching failure is not an option payloads, there are systems and processes and checks and balances that drive a lot of cost into the system, and procurement approach drives cost into the system and price into the system. Who carries the risk does affect the price. If I'm carrying all the risk, my price goes up, I will increase my margins. That's how business works. And certainly at PWR, we have been and continue to work what is under our control and partner with our customers for what they control out of that equation. But I can tell you from our perspective, because I do have launch failure experience, we are not jeopardizing mission success, and we will not jeopardize mission success. We need to provide that mission success at a more affordable price point, but it's a huge gray zone, and you don't know when you cross it. And we are not going to risk that at all. Choosing to ignore the facts does not mean they cease to exist, and we must recognize and deal with what exists. Physics is real, and it hasn't changed near as I can tell, and the realities of business economics are real. Price has to be greater than cost. So the bottom line in this business, launching often, launching with tempo, and launching reliably is what counts in the long run, is the most cost-effective and healthiest approach. And so for us at Pratt & Whitney Rocketdyne, we will continue to invest in technology and our design and manufacturing processes, but we'll do so with a commensurate expectation of return based on the realities of physics and economics. Thank you.
Thanks, Jim. Next up is Frank McKenna from International Launch Services.
Thank you, and I'd like to thank Frank for inviting me to be on the panel, and the Space Foundation, and of course our customers in the audience. It's a great opportunity to represent ILS and Kurnichev here today. Two of our colleagues who are in the audience, Janice Starsik and Jim Kramer, are with us today. Catch them on the break. I'm sure they'd love to share more about our story. This is the first time we've been at the symposium since we became an independent company in 2006. So I thought I'd take the opportunity to give you an update of what we've been doing in the last 6 years. And it'll come at it from a commercial perspective, creating value for our customers, and touch on a number of the subjects that Jim just related to, and our first panelist from United Launch Alliance. So first off, this slide here shows what we've been doing to create value for our customers. The Proton system is focused now with our business on a heavy lift performance. The system itself has launched 375 times. 71 of those launches have been through ILS Proton, all commercial launches. 41 of them have occurred in the last 4 years. We've increased the performance of the vehicle and its capability through a phased program, and that has been 100% successful, increasing its throw weight to GTO to 6+ metric tons. And we are operating off of 2 commercial pads at Baikonur, 3 to handle full system throughput. Demonstrated secure and schedule assurance with 12 to 14 systems produced annually. I attest to what Jim is saying. Volume does matter. Repeatability does. Quality matters. We've improved the integration timelines to less than 5 months on these large geostationary satellites. We've reduced the commercial launch centers from 5 weeks to 3 weeks. And we've demonstrated just last year with dual processing facilities, launching 6 systems in 90 days. We've streamlined our processes, we've put competitive terms in pricing, and created a business that is profitable and on a sound financial foundation and creating good value in the industry. The system is very robust and flexible. It's single dedicated launch or multiple launch. I'm focusing on the commercial program. Of course, there's a federal program that is operated here, which next year will launch an MLM module to the space station. It's also been selected by ESA to launch the 2 ExoMars probes. But what I'm focusing on is really what we've done in the commercial GEO broadband communication satellites. We've launched a lot of new technology with KASat, Viasat, SkyTerra 1. We're going to launch the initial constellation of Global Express, which is mobile Ka-band for Inmarsat. Intelsat 22 we just launched, which is hosted payload. I'll focus a little bit on that for this audience benefit. We have 10 hosted payload, shared payload type of operations. In our manifest, the most recent was launched on March 25th with Intelsat 22. Show a brief clip of that in a minute. But also, we'll launch YASAT the following month in April. We have SES with the EGNOS payload for ESA coming up in June. We've got an ANIC payload coming up the end of the year with X-band capability. Global Express will put up the first 3 satellites to initiate that constellation for mobile Ka-band coverage. Turksat, we're putting up a satellite for them, and the Mexican government will put up an L-band satellite for them. The next slide really focuses down on our value proposition in hosted payloads. This mission occurred on March 25th. It's the first Boeing 702 MP platform. Intelsat bought 4 of these, Inmarsat bought 3. This platform is going to be a mainstay in the industry. This particular system had 72 C and KU band transponders on it, as well as UHF capability, approximately 20 channels there. The satellite was built in 29 months. This was the first Proton SSTO mission. We created additional value for the customer and its station keeping capability out to 18 years. We accelerated the availability of that UHF capability by holding the cost and schedule for the Australian Defence Forces. They claim to have saved over $150 million on the program compared to a free flyer. And we, of course, Intelsat, our prime customer, generated additional revenue to create a sound foundation for them. I'd like to show a brief clip from our customer, David McGlade, who's the chairman and CEO of Intelsat, what his words are about this. They currently are the largest commercial operator in the world. 51 satellites in their fleet operating. They actually fly about 76 satellites. We're proud to have served them in this capacity. So we'll show that, a liftoff of this, and what I'd like to highlight is the flexibility of our upper stage. So for the engine guys who are on the panel, you're going to see a beautiful performance by the Breeze M upper stage here momentarily. So if I could have the video, please.
I can't remember a launch program attracting more industry attention. Intelsat 22 is of great interest because it includes a dedicated UHF payload under contract to the Australian Defence Force. The close working relationship between the ADF, Intelsat, and Boeing has produced a commercial alternative to typical military space programs. Its custom designed KU-band beams are tailored to support our customers' mobility needs. And our media and broadband customers in Europe, Africa, and Asia will also benefit from the satellite's 2 C-band hemibeams. We're pleased that ILS is able to honor its commitment to launch Intelsat 22 on schedule, and we look forward to working with them again for the launch of Intelsat 23 later this year.
Hours, 13 minutes after the second burn, the third BRIESM burn starts. Soon after this burn shuts down, the depleted auxiliary propellant tank is jettisoned, and the fourth BRIESM burn begins. The resulting orbit is called the transfer orbit, where the apogee is greatly increased to a supersynchronous altitude of 65,000 kilometers. These two burns add up to almost 18 minutes and span from the western side of China to the southeast side of Australia. During the coast phases, the BRIESM performs attitude maneuvers in order for Intelsat 22's solar arrays to be exposed to the sun at a predetermined solar illumination angle, which is designed to satisfy its thermal and power requirements. 10.5 hours later, during the fifth and final BRIESM burn, the orbital unit will perform a large plane change maneuver from 50.5 degrees to 28.5 degrees inclination and increase its perigee to about 3,800 kilometers in a 3.2-minute burn. About 12 minutes later, the Intelsat 22 satellite is separated from the BRIESM to reach its targeted supersynchronous transfer orbit. The total mission time from launch to Intelsat 22 spacecraft separation is approximately 15 hours and 30 minutes.
So thank you very much. That's what we do every month, every year, and we're proud to serve our customers and look forward to seeing you during the rest of the panel.
Thanks, Frank. Next up is Clay Mowry, and I think we should ignore that clock. We're here until noon, so.
I'm going to be short. I promise to be short. Thank you, Frank, and thank you to the Space Foundation for having me back. I'm going to show you a short video clip, do a little bit of voiceover for you. Everybody else had, well, Jim didn't, but everybody else had great videos the last couple of years, so I felt bad. I figured this year I'm going to run a video, show you some rocket launches, so here we go. Arianespace has been around now since 1980, so 32 years we've been launching spacecraft into orbit. The video you're seeing here today depicts our new theme of Power 3, which equates to the three launchers that we're now operating down on the equator: the Ariane 5, the Soyuz, and the Vega launch system. Since we were founded, we've launched over 205 times now in total. We've placed 299 payloads into orbit. We've got our next launch coming up in middle of May with 2 satellites, commercial satellites for Lockheed Martin that we'll be launching, and then we're launching again in June and July. Again, dual launch missions for commercial satellites going to geotransfer orbit. Here you see the solid booster separation from the Ariane 5. This is the new Soyuz launch facility that we constructed down in French Guiana. That's the mobile gantry system that surrounds the Soyuz launch pad. And we had last fall the first launch of the venerable Soyuz rocket from French Guiana, lifting the Galileo in-orbit validation satellites for the European version of GPS into orbit. Very proud to have that launch take place in October of last year. In total, in 2011, we launched 9 times and placed 29 payloads total into orbit. It included a September 21st launch of the commercially hosted infrared payload aboard SES-2, and that payload is for the United States Air Force and SMC, and we're very proud to have that launch take place. Total last year was 5 Ariane 5 flights, 4 Soyuz flights, 2 from the 2 that I mentioned from French Guiana, and an additional 2 from the Baikonur launch facility, where we work with our StarSem affiliate to launch satellites for the Globalstar mobile satellite constellation. As was mentioned earlier, we've now launched the Ariane 5 some 47 times in a row successfully, 61 times overall in the program, almost a decade now of launch successes for Ariane 5, so we're very proud of that. What you're seeing now is the Vega launch of our new light launcher, the Vega, which launched in February of this year. So completing, as I say now, with 3 launch systems. And with those 3 systems, we can basically place any payload into any orbit. So we're doing missions that range from supply missions to the space station with the European Automated Transfer Vehicle to constellations of satellites in low Earth orbit, as well as scientific and research satellites, and then our mainstay with Ariane 5, which has been dual launches of communication satellites. On the hosted payload front that Frank mentioned, we've done 41 total launches for national security missions, including 3 different hosted payload launches over the past several years. So we're very proud of that track record and to continue our operation. Looking forward into this year, we're trying to conduct 7 Ariane 5 missions. We've already completed 1 mission, ATV-3, to the International Space Station, which was a record for us, over 20 metric tons delivered into low Earth orbit, into an ISS orbit. We've got 2 more ATVs to go in the European system now, one coming up next year and the following year after that. Also supply missions to the ISS with ATV. We're looking at maybe 2 to 3 more Soyuz flights this year, and as I mentioned, the Vega flight we had. And finally, obviously, we're looking very much forward to launching the James Webb Space Telescope for NASA in cooperation with ESA in a few years. So we've got a hefty schedule ahead of us, and we're really looking forward to exceptional launch cadence this year. Thank you very much.
Thanks, Clay. Next up is Charlie Precourt, ATK.
I presume is a clicker. Well, good morning, and thank you for having me to the NSS Foundation. I really appreciate the opportunity to spend some time with you today. You're probably all wondering why you're wearing a name tag that has Liberty on it, and I'm proud to be able to spend some time here with you this morning introducing that concept to you. As a matter of fact, it was right here at this symposium 2 years ago, the guy sitting to my right and I managed to get together for a little bit. I approached him about the concept that we had some complementary skills and capabilities that could deliver on a new innovative approach for spaceflight and for launch system capabilities. You just saw a lot from the Ariane 5 that leads to proven reliability track record, and one of the things that they can boast is among the lowest cost insurance rates for commercial launch in the world. We saw an ability to partner with a competitively commercial partner to match capabilities with us that is proven out over the last 2 years to bring on a very new and innovative. I want to show you what's the new and the innovative parts of this that make for a very promising concept in the future. I want to give some credit too to NASA because at ATK, obviously we are working our way through all of us up here working our way through the transition from the space shuttle program. And NASA has set the bar quite high for all of us, and I think appropriately so. The message is loud and clear, and our marching orders are very clear, and that is to deliver ever-improving reliability and performance at increasingly more affordable costs. So what we saw here with the Liberty Transportation System was an ability to leverage an immense amount of prior developmental costs and systems that were flying. We used for the Liberty a first stage that's comprised of the space shuttle derivative solid rocket booster, and then we take from the Ariane 5 that you just saw a video of the core stage, LOX hydrogen, and marry it to the Liberty first stage to produce a vehicle that's capable of 20 metric tons to low Earth orbit. And today we have, over the past 2 years, evolved to be able to provide a full transportation system, including a high-performance spacecraft for crew and a high-volume payload shroud and interface for payloads for cargo and other payloads. The system obviously leverages a very strong international partnership, one that is not new with this particular offering. We have been working at ATK with EADS and Astrium on things like the Airbus, our commercial provided composite materials. You heard from Jean-Lan, the partnership between GE and SNECMA that delivers engines for the Boeing 737 that flies around the world. And those existing partnerships between industry, especially across the Atlantic, are enabling us to leverage a lot of prior investments. And then down at the Kennedy Space Center where we envision launching, we're leveraging the infrastructure that is in place, an ideal vehicle to use that infrastructure. Thinking forward about what we want to offer, we want ever-increasing reliability and lower cost, a very challenging task at hand. We believe that safety and reliability are an actual business proposition. We think that there is an opportunity to double the reliability of today's existing launchers with this system, and that's because it has minimum moving parts. We're able to do 20 metric tons with only 2 engines, 1 engine per stage, with a stage that has, on the first stage, an SRB that has a very impressive probability risk assessment of 1 in 8,000. For those that are not familiar with that, that's an immense level of reliability. As compared to today's systems, I think doubling reliability is a very achievable goal. With the Vulcane 2 upper stage engine, it's a very proven 47 consecutive flights system that is a simple gas generator. It's not throttleable and it is not restartable. Those are two capabilities this mission doesn't require, so the simplicity increases the reliability. So we believe that in NASA's mission area, a greater than 1 in 1,200 probability of loss of crew is completely achievable, and that's an order of magnitude improvement over the space shuttle. The large lift capability also benefits the development schedule and overall system safety because we have immense performance margins for most missions. Another emphasis area is building it for minimum cost through affordability. We draw from a very large heritage of commercial programs, those that you see listed here, that brings in the best experience around the world for a new approach to doing business. So the innovation is not so much in new technologies, as Jim said earlier. The physics is constraining us. We're trying for ever and greater performance in technologies, but we're also more able today to leverage innovation in the way we do business. And again, NASA has raised the bar for us in enabling us to do a number of things. We have streamlined ATK operations and production processes across our workforce. We have workforce reductions of over 50% while still delivering to the same milestone schedules since 2009, consolidating work centers and closing more than 250 facilities, and value stream mapping the entire manufacturing process. We, with NASA, approved over 420 process changes. As an example, 47 moves of a piece of hardware in the assembly line has been reduced to as few as 7 and taken out literally thousands of hours of production from the system. And in one measure, we're able to, for the SLS system, for example, which will use the same booster in its test flights, 42% of the total propulsion energy for 18% of the total vehicle propulsion cost. Finally, the vehicle with a simple arrangement is very highly available on launch day. A couple of pie charts here that show the effect of launch delays. The space shuttle had over 720 launch days delay in missions that did not include weather for technical reasons over the life cycle of that system. That was over $5 billion in cost to the life cycle of that operating system. And in this chart, you can see the contributors to that. The solid rocket booster contributes to less than 2% of that. And having the fewest number of technical systems to manage, the fewest moving parts, enables us to raise the bar on this availability number, where we should see at least a doubling of the availability and or half the number of delays or less, which dramatically will lower the life cycle cost of the system. Furthermore, the other way to produce cost savings is to leverage synergies across systems. I already mentioned where these derive from. As we go forward, I think across the government we need to find ways that systems can be leveraged across multiple mission areas and multiple configurations. A very simple concept to grasp. In summary, I think we should look forward to Liberty to bringing innovation with a new partnership that fills capability gaps across the Atlantic. We've got systems capabilities, business experiences that can be leveraged in a new way. And we've made significant progress over those last 2 years since Clay and I first talked here about it. And 4 design reviews at NASA have been completed. We're using extensive lessons learned to bring this system to bear. And the commercial crew initiatives are creating a very positive change in the industry, benefits that will extend to numerous other government programs. I also have a video, but it's a little different kind of video. If we could roll that. It talks about what we really should be thinking about is setting ourselves up for the future. Innovation today that'll deliver for the future. I think we may have the wrong one.
To continuing to provide
this is
our
a different video.
Americans the opportunity to see that flag when they're not sure that they're ever going to see it again.
Could we, there we go.
Liftoff of Orbital's Minotaur 4 rocket carrying SBSS.
Can we get the bag in? I guess we'll have to stop the video there.
Stop the video.
We got out of sequence on video. Sorry about that.
Do you have a pre-court video there? Maybe we can come back to it.
Okay, we'll come back to it.
Thank you very much. Sorry about the video.
Thank you.
And next is Julie Van Cleek, who is going to talk to us about some new rocket engines they're working on, I think.
Thank you, Frank. I'd like to thank you and the Space Foundation for inviting Aerojet to participate on this panel. And today I'd like to provide maybe our perspective on the challenges and opportunities we see in launch vehicle propulsion and where we might end up in 5 to 10 years. Does this just start on its own?
Push the green button. Push the button.
Well.
Can we have the first slide, please? They're working on it.
There we go.
Oh, there it is.
Can I go backwards?
There you go.
Okay. What we're going to do is, as you hear things at the symposium, you hear a lot about change and challenge and so on, and there is certainly a lot of challenge in our industry right now, but I think there's also a lot of opportunity. I think one of the interesting things we all have to think about being in the launch business is it is as you've heard from some of the other panelists, this is a business that's built on reliability and heritage, and change is one of those things that you look at pretty carefully in this business. And so as you see the challenges and opportunities about you, you got to ask yourself, how much do I want to change? How much can I change and still meet that mission that's so important, to our country and to our world? So I thought I'd start off with this business axiom. You cannot expect to meet the challenges of today with yesterday's tools and expect to be in business tomorrow. And ask the question, does this really apply to launch vehicles? And when you think about tools, I think about our products, I think about our processes, I think about our people. And like I said, change is one of those things that, and I can know this from experience, with motors and engines, you gotta, if you make a little mistake with a change, you can also have a big surprise that you didn't anticipate. So I'll ground you first in where Aerojet is in the launch vehicle business. We've been in the launch vehicle propulsion business since there was a propulsion business for launch vehicles. Over 50 years, we're very proud of our mission success record. We take nothing for granted. We're every launch, we look at it one at a time, every product one at a time, and try to make sure we never get complacent, because without that type of reliability, we won't be in the business. We provide solids, liquids, we provide steering propulsion. We also are very heavily involved in the payloads that these launch vehicles lift. We're also very proud of the technology that we've brought to this industry. We've been in business, we just celebrated our 70th birthday last month. So we're an older company, but we like to think that we continue to refresh ourselves. Technology's always been big for our company. We're very proud of all the firsts and the new things that we do with rockets and motors and systems. But I think the thing of the past 5 to 7 years that we're very proud of is how we've re-engineered our business model and how we're continuing to do that for the future, because that's, I think, what's going to be critical for staying in business and prospering. This slide, the top slide, is a picture of our growth over the past 8 or 9 years. In the first few years, there were some acquisitions up to about 2000 and late 2003, early 2004. But since then, it's been predominantly organic growth. And the bottom line, the green line, is our workforce. And what you see is a fairly flat workforce line. And part of it is we've driven cost out of our system in many, many different ways. But we've also re-engineered the business model. We've stood back and said, what's important to us, what's important to keep in the company, how can we partner, how can we best attack that affordability question. And as we've evolved the business and operating model inside, we've had some very good results, not just with the financials and the business growth, but with the type of products we've evolved as a company. We're fairly diverse, as I mentioned, solids, liquids, electric. We deal from the very small to the very large, and one of the things we've learned throughout this process is how to become far more agile. We have a very cross-trained workforce. We have cross-utilization of facilities. Allows us to be very agile in the marketplace and to move from, challenge to challenge with different groups of people. They could be working on one product one day and another product another day. And we've been able to do that successfully and still maintain our mission success record. So we think that's a very important thing for our company going forward and for facing the challenges, that look to be in front of us. And as I look at what's in front of us, I have a chart. It's pretty simple. What are the challenges? What are the opportunities? And some of them are high level. Budget pressures, I mean, everybody in this room is probably feeling them and seeing them. The demand is down. There's some overcapacity, if not a lot of overcapacity in the industry. Sounds like we're all working on that to some degree. Industrial base and workforce stress. We've got some interesting demographics in this industry that many of us are facing. And some industrial base challenges, particularly in propulsion. It's becoming a worldwide market for a fair period of time. It wasn't that, but it certainly is now. And then we hear a lot about lack of competitive pricing in some of the U.S. products. And I'd say some of these challenges are in some ways opportunities, but if I look forward and say, what are the opportunities that we see? Space is not going away, and if anything, it's increasing in importance worldwide. And for all of us, I think that's an opportunity. We're seeing more government interagency cooperation. I think as budgets get tight, we see the DoD and NASA examining what they're doing, where they're going, and we're seeing signs of more and more cooperation there. We think that's an opportunity. There are technology advancements. As Jim said, the rocket equation is the rocket equation, but there are some advancements in areas, particularly in the area of in-space, that can have a dramatic effect on launch vehicles. Many new people in the industry over the past 10 years. I think that's very healthy for the industry. I think the new ideas, the new concepts, new products, those are all a very healthy thing for our industry if we know how to integrate them properly and, again, maintain that ever so important mission success element. And, again, increase in new players worldwide. And so what we're doing as a company to try to meet these challenges, to try to figure out what we need to be for the coming decades is continuing to focus on that business model, because affordability is critical to all of us. Again, for us, the agility side of it is very important. And then I also add the word sustainability. And when I say sustainability, we want to be in this business for the long haul. The models we had in the past where we might keep many type of capabilities inside, we're starting to look more looking at these and looking at the potential partnerships that we can forge outside the company, because we think in that way we can be more sustainable as a company. We don't have to maintain everything as core. Again, I mentioned the cross-training and cross-utilization, which is critical. We're looking very hard at the product development process itself, trying to drive more affordability. There have been a number of advancements that can be applied to the process. Again, the workforce is the demographics as well as the STEM issues are something we treat very seriously. We're looking at a number of aggressive and non-traditional approaches to bringing the new workforce in. And then again, continuing to sponsor those enabling technologies that could change the equation here relative to launch. And so just a quick summary of some of the things that we're doing and we hope to see in the next 5 years. Again, I do plan and we do see that we will continue to evolve our business model focused on the things shown on the chart here. Advanced in-space propulsion, be it electric, nuclear, depots, those can dramatically change the launch equation and lower the cost of launch. And so we're investing in those and making many of those technologies a reality. And then as Frank alluded to, we're also looking at what is the next step in launch vehicle propulsion. And we're looking at a number of modular, multi-user elements of propulsion, both booster and upper stage. So we truly believe a sustainable, competitive launch vehicle infrastructure, will be here, will be a part of this country. We have the will and the discipline to achieve it. And so as you look at that challenge or that business axiom I had on the first slide, I guess the way I'd answer it, relative to launch vehicles, you got to be thoughtful when you evolve these tools, integrate the new products, the new processes, but I think we must do that if we're going to be in business tomorrow. Thank you.
Thank you, Julie. And last is Gwen Shotwell. And I actually just got a question that I'll start off with for you. That are you going to be able to make the April 30th date?
Well, I hope so, yes. We just passed our flight readiness review with NASA.
Did you pass it, or were there some open issues?
Well, there's still always forward work at these, but yeah, we still look good for April 30th. It's really exciting.
Thank you.
Thanks very much. So it wouldn't be a SpaceX presentation if we didn't have a video, so I'm going to roll one, please. Hopefully. Slides, please. Frank, I want to take the opportunity to thank you and the Foundation for inviting SpaceX back to speak on this panel. And I will blaze through these, just touch on highlights since we last spoke here. We have added almost 500 folks to our staff. We're nearly 1,800 employees, and I'm very proud of each and every one of them. They all work incredibly hard to help achieve our goals. We've also expanded our factory in Hawthorne, California, as well as our Texas test site. If you happen to find yourself halfway between Austin, Texas, and Dallas, you may want to take a stop in at our test facility there. It's like launch every day. We're firing rocket engines every day, and just a couple of weeks ago, we fired 7 engines on a day, which is great. We are just setting up our site at Vandenberg Air Force Base, again, the former Titan IV pad Slick 4, and we're working on establishing a commercial launch site as well. I think that came out in the news this week. Currently Texas, but we're looking at Hawaii, Florida, and Puerto Rico as well. So we've taken a sane approach to developing our capabilities. We started with a little rocket called Falcon 1 to test our technology, our business model, as well as our staff. Moved into Falcon 9, launched that successfully twice in 2010, and for the past year or so have been working on taking that Dragon capsule, which we flew, orbited, and entered, and turning that into a capsule that can reliably berth with the International Space Station. We upgraded our avionics and our software to be dual redundant per station requirements. We added the interface to the ISS, enhanced our comms, added a power generation system. So we've definitely been busy, on top of also looking at turning that cargo capsule into a crew carrying capability. We've also been working on the Falcon Heavy. We hope to have that vertical at the launch site at Vandenberg late this year or early next for a flight sometime later next year in 2013. Just to get a sense of where we are, in the EELV lingo, Falcon 9 is a medium lift launch vehicle, and Falcon Heavy is an intermediate to heavy class launch vehicle. Falcon 9, we're doing commercial deals right now for $55 million US dollars, and Falcon Heavy, we're about ready to sign our first commercial deal for under $100 million. It's great. A couple of beauty shots for the next flight, hopefully lifting off on April 3rd. Keep in mind, I'm trying to keep expectations where they should be for this. This is a demonstration flight. First time a commercial company has ever attempted berthing with the International Space Station, and we're trying to stay sane in the process. Vehicle's been ready for quite some time, probably almost a year. Falcon 9 vehicle, and we've been waiting on Dragon. We've kept the team sharp with a number of wet dress rehearsals, culminating in a final full flight readiness test on March 1st. We have loaded cargo for Dragon. At least the early load cargo. We have some late load cargo that we'll put in this weekend, I believe. Load hypergalls, go vertical the following week for a final static fire on the pad, and hopefully lift off on April 30th. We do have ability to phase with the space station approximately every 3 days. So if we don't make April 30th, we should have an opportunity on May 3rd. Keep in mind, this is an extremely challenging mission for anybody, but for us especially. This will be the first instantaneous launch window, which we've had. So we're very much looking forward to it, but there's definitely a lot of work still. What I think is really critically important is the concept of the business. You can't be a long-term reliable partner for your customers if you don't have a steady and critically important, a broad market base to keep your business healthy regardless of some downturns in some sectors. So we're quite proud of the business that we have established at SpaceX. We've been free cash flow positive and profitable for the last 5 years. We are going to have to launch this year in order to maintain that, but we're looking to do that hopefully 3 times this year. Most of our business is actually in the commercial sector, 47%, although about 40% is business by NASA and others. And we also have a pretty healthy international business sector as well at 13%. We've signed 10 deals since I spoke last year here. And what's critically important is we seem to find very good success in the Asian marketplace, which is probably the fastest growing marketplace for launch on the planet. We've done 5 deals in Asia in this time frame. I know I'm rushing. Okay, want to be clear about what the market is for launch, both in terms of dollars as well as numbers of launches. There is a lot of room for multiple launch providers. What's key is, can you provide reliable launch at a price point that's attractive to customers? There's plenty of business. There's 40 to 50 commercial launches competed annually, which currently represent about $5 billion a year. There's a lot of lumpiness in that market on the LEO side, certainly, as compared to a $3 billion a year market with the DoD for 6 to 8 launches annually. So the message here, without going into excruciating detail, is there's lots of opportunity for multiple providers to provide services to customers. And I guess I will finish there.
Thank you, Gwen.
Yes.
We are just about out of time, and I should apologize to the panel. I thought this was an hour-and-a-half panel. It was an hour and 15 minutes. And so we may have to do this without questions. I've gotten a lot of good questions here. They've also found Charlie Precourt's video, which he says lasts 30 seconds. So could we see the video? And then if there's any time at all, if people want to stick around, maybe we can ask some questions after that. I'm getting a head shake over there, no video. All right, I'm going to ask one good question that I got from the audience, and that's that several panelists seem to suggest that reliability trumps affordability, that they may be incompatible. Why? Wouldn't affordability drive simplicity, which would increase reliability? And that plays, I think, right into what's going on with the at least U.S. space policy right now, trying to drive down the cost by going to the commercial sector more. So, Dan, I see your hand.
Look, I'll take a cut at it. They're hand in hand. They're both requirements that our customers need. And to be successful in the business, you're going to have to deliver both. I think affordability and reliability have to be considered in the total life cycle cost. You can have an affordable rocket. If it is not reliable, you're not going to have an affordable solution to your customers. So you've got to play both. I didn't hear the panel myself saying that one was exclusive of the other.
Anybody else?
I agree. I didn't hear the panel saying that either. And as a matter of fact, I believe that affordability is a business proposition for what we're all about. The higher the reliability, ultimately, the more affordable we get.
Thank you.
The only thing I'd add to it, Frank, is our customers are extraordinarily schedule sensitive. They want to be delivered into orbit on time when the satellites are available, and so part of that affordability equation is not just the pricing, it is really lowering the lead times to less than 30 months to get the satellites into orbit.
And I'd add, being ready to go when they are, being able, if their schedule changes, being able to support their schedule changes as it comes up and not have their schedule change create a bigger delay because the launch vehicle can't adjust.
Right. And I guess the comment I would add to that is, what's the definition of affordability? If I have $10,000 and I go in to buy a Porsche 911 and they won't sell it to me for that, and I scream they're unaffordable, I don't think I'm going to get much traction.
I think what's critically important is that reliability does not have to equal high cost, and that you can come up with, if you've architected your system appropriately, you can fly incredibly reliably for, we'll call it low cost.
Anybody else? Clay?
You know, we've flown 47 times in a row over the last 9+ years without failure, and you know, consider ourselves to be a leader in the commercial launch marketplace. I think, as a number of these other guys mentioned, the two go hand in hand. You have to be ready when the customer's ready. If there's a delay at the end of the day, if the satellite's late showing up, we're the ones that bear that cost. But we have to be ready on time when the spacecraft are there and launch them reliably. What comes with that reliability is market success, and you get low insurance rates. And so I think those things, they do go hand in hand.
Great. So thank you all very much. Thank you for your patience. And let's give our panelists a big round of applause.
It's in the red by 2.
Frank, we can do that video. We can do the Charles Precoat video. Yep. Let's do that.
This just in, the Charlie Precoat's video has been found and can be played.
The last video.
So here, are we going to see it?
My fondest dream is becoming an astronaut. I will see space and planets. I will hear the countdown clock. I will taste astronaut food on a mission. I will touch the controls. I will smell space. Inside, I will feel happy and excited. I wrote this poem.
Good. Thank you again.
All right, thank you all very much. It's lunchtime, so head out. I think